Hello everyone, this is Priyanka of Sri Venkateshwara College of Engineering, and today I am here to present a presentation on conversion of epsilon NFA to DFA. So the contents I am gonna cover in this topic are what is the meaning of DFA, NFA, then epsilon closure, then the steps we require to convert epsilon NFA to DFA, then a small example based on this conversion. So first let us know what is the meaning of DFA. DFA can be abbreviated as deterministic finite automata. On each input there is one and only state to which the machine will be moving from the current state. So for a particular input character, machine goes to one state only. There is no multiple states here. Next, DFA consists of five tuples Q, sigma, small q, f, and transition function. Q represents the set of all states where it can be Q0, Q1, Q2 in the machine. Then sigma, it is the set of input symbols where the input symbols can be A, B, 0, 1, etc. Then small q represents the initial state, it is the starting state of the machine. Then F represents the final state. Then transition function, it says how many transitions takes place from one state to the another state. So let us move on to the NFA, where it can be abbreviated as non-deterministic finite automata. On accepting an input string, it may enter into the multiple string. So let us see some important points between NFA and DFA. So every DFA is NFA but not vice versa. Both NFA and DFA have same power and each NFA can be transmitted into DFA. There can be multiple final states in both DFA and NFA. NFA is more of a theoretical concept. DFA is used in lexical analyzer in the compiler. So before moving on to the conversion of epsilon NFA to DFA, first we have to know what is the meaning of epsilon closure. So epsilon closure for a state A means that set of states which are reachable from A on the input string epsilon only including the state A itself. So let us see example. So in this example, for Q naught, epsilon closure is that state itself, that means Q naught. Then with the input string epsilon, it is going to Q1. So epsilon closure of Q naught is Q naught and Q1. So for Q1, with the input string epsilon, it is not going to any other state. So epsilon closure of Q1 is Q1 itself. So for the state Q2, that state itself, then with the input string epsilon it is going to q1, then with the input string epsilon it is going to q3. So epsilon closure of q2 is q2, q1, then q3. Then for q3 there is no out input strings where it is not going to any other state with the input string epsilon. So there is no outgoing strings from q3, there is an input string but we can't consider that. So for q3, the q3 that states itself. Next, the required steps to convert the epsilon NFA to DFA are: take epsilon closure for the starting state of NFA as a starting state of DFA. Find the states for each input symbol that can be traversed from present state. This means that take union of transition value and their closure for each state of NFA present in current state of DFA. If you found a new state, take the state and repeat the step 2. Repeat step 2 and step 3 until there is no new state present in the transition table of DFA. Mark the states of DFA as a final states which contains the final states of NFA. So convert the following NFA with epsilon moves to DFA without epsilon moves. So let us see the steps to convert this. First, find out the epsilon closure of Q, R and S. So for Q, the epsilon closure is that state itself. Then with the input string epsilon, it is going to R. Then it is going to the S. So epsilon closure of Q is Q, R, S. Then epsilon closure of R is that state itself QR. Then with the input string epsilon, it is going to S. So R and S. So for S, there is no outgoing string with the input string epsilon. So the epsilon closure of S is S itself. In this, the new state is QRS and RS. So by taking QRS, we have to take the transition of QRS comma A and input B and input C. So epsilon closure of transition of Q comma A union transition of R comma A union transition of S comma A. So epsilon closure of transition of Q comma A with the input A, Q is going to that state itself, that means Q. So Q union with the input A, R is not going to any other state. So it is null. Then S comma A, then S also it's not going to any other state with the input A. So 5. Then Q epsilon closure of Q is QRS. It is already existing state, so we can't consider this as the new state. Then we have to check it with the input P. Same epsilon closure of transition of Q comma B union epsilon closure of transition of R comma B, then union transition of S comma B. So we will get null union R union null. So epsilon closure of R is R comma S. So this is the new state. We can consider this. Before finding with the new state, first let us complete this QRS with the input C. So for C, we will get the state as yes. This is not the new state, it's already existing. So first now we have to take the new state R comma S and we have to find the transition of R comma S with A, B, C. So transition of R comma S with input A, with input B, with input C. With input A, we are getting all as null, so answer is null. Then with input B, R is with input with input B with input B, the state R is going to that state itself. So we can take as R, then union with S with input B, it doesn't going anywhere. So we can consider it as null. So epsilon closure of epsilon closure of R is R comma S. So I have written here. Then epsilon, then we have to find the transition of R comma S with the input C. We will get final as epsilon closure of S. So epsilon closure of S is S itself. So it is not the new state. We didn't get any new states here. So we can conclude with the DFA, the final DFA. We got first new state as Q comma R comma S. Q comma R comma S. So Q comma R comma S with input A, it is going to Q comma R comma S. So Q comma R comma S with input A, it is going to Q comma R comma S. So it is a self loop. Then Q comma R comma S with input B, it is going to R comma S. So we have to take the another one state R comma S. Q comma R comma S with input B, it is going to R comma S. Then Q comma R comma S with input C, it is going to S. Then Q comma R comma S with input C, it is going to S. Okay. Next, R comma S with input A, it is going nowhere, it is null. Then R comma S with input P, it is going to R comma S only. So self loop. Then R comma S with input C, it is going to S state. So here we will get. Then the final state when it is in epsilon NFA is the state S. Though so the same we have to conclude here. Then the final states of the DFA is also, so S is present here, so we can mark this as a final state. Then S is here present here, so we can mark this as a final state. Then this as a final state. So We got 3 also final state. So this is the DFA without the epsilon moves. I hope everyone understood. So thank you. Bye bye.